Okay, we're going to start lesson 3.1, which is our first lesson in Unit 3. And this unit is really all about systems of equations and inequalities. So in this very first lesson, we're going to make sure that you understand what a system of linear equations is. And a system of linear equations consists of two or more linear equations that have the same variables. And we are going to consider those two or more linear equations all on the same coordinate plane. Now, a solution of a system of linear equations is an ordered pair that satisfies both equations in the system. And I think that you're going to understand what this looks like when we go to the first example. But it was really important that you understand what that ordered pair means to both linear equations by watching the video that preceded this one regarding verifying whether or not an ordered pair is a solution to a system of linear equations, because that kind of gives you an idea of what we're looking at. Now we're going to visually solve or look at what the solution means on the coordinate plane. And you can solve these systems by graphing or using algebra. We're going to look mainly at graphing for the first lesson, and then we'll move into the algebra solutions in the later lessons. So our first example, we're going to use this graph to solve each linear system of equations. So what we're given here is we are given an equation, 3x minus y equals 1. And when I create a table and I graph that line, I get this line right here that I highlighted in yellow. I have another equation, x plus y equals 7. And when I create a table and I plot those points, I get this green line. And lastly, we have two equations here, x plus y equals 3, which is modeled by this line. But I also have 2x plus 2y equals 6, which is modeled by the same exact line. And I think if you just look at this, you can see that if I divide each term by 2 using the division property of equality, I would end up with the same exact equation. So both of these linear equations are represented by the same exact line on the coordinate plane. So my first task is I want to look at this first system that they would like us to solve. So this first system, we're going to look at these two equations, 3x minus y equals 1 and x plus y equals 7. Well, 3x minus y equals 1 is the linear equation represented by the yellow line, and x plus y equals 3 is represented by the blue line. So we look at the yellow and the blue line to see what point they have in common. The point that they share, that single point that both lines share, is called the solution to the system. So this point would be considered the solution to the yellow and the green and the blue line. Well, that ordered pair is 1, 2. That means that if I were to put a 1 in for the x value and a 2 in for the y value, it would make both equations true. And again, the video that preceded this video, the one that says verifying solutions, is really important so that you can understand what you would do with this ordered pair to verify that it would work in both equations. The next system that we have is this system right here, x plus y equals 7, and 3x minus y equals 1. X plus y equals 7, and the color coding really helps. The x plus y equals 7 is that green line, and 3x minus 1, 3x minus y equals 1 is the yellow line. So we look at the point that both of those equations share, and it's the intersection point, which is 2, 5. And 2, 5 would be the ordered pair that makes both equations true. So if I want to double check to make sure that 1, 2 is indeed the solution, and what I'm going to do here is I'm going to go back and I'm going to color code so that you can see. I just would prefer this to be color coded. This is the red that I marked in red, the red system. And I'm going to come over here and I'm going to mark this red as well, so that everything's coordinated. If I put a 1 in for x and a 2 in for y, it makes the first equation true. 3 minus 2 is 1. If I put a 1 in for x and a 2 in for y, it makes the second equation true. This ordered pair is the solution because it creates a true situation for both equations. It's the point that both lines share. So it is the ordered pair that is a solution to that system. Now I'm going to come over here and verify that 2, 5 is indeed a solution to both linear equations. I have 2 plus 5 equals 7. I put a 2 in for x and a 5 in for y. That is indeed true. 3 times 2 minus 5 equals 1. 6 minus 5 equals 1 is also true. This right here, this ordered pair, 2, 5, is indeed the solution to the system. Now this next equation, or these next two systems are pretty interesting because we're going to be looking at x plus y equals 7. I just want to see what colors I used here. X plus y equals 7 along with 2x plus 2y equals 6. So before I begin, I want to highlight my lines just because the color really helps to see which lines we're going to be comparing with one another. So they want us to compare 2x plus 2y equals 6 with x plus y equals 7. Well, the blue line and the green line appear to never intersect. How can we tell that they're never going to intersect? Well, it looks like this point, if I were to look at this as an incline, to get from one point to the next point on the incline, I go up 1 and left 1, up 1 and left 1. Now, if the blue line is going to increase at that same incline, then the two lines will never touch. It'll be like stairs that are on different levels that would never intersect because their rate of increase or decrease is the same as the other line. So I look at this and I say the green line is going up 1, left 1, up 1, left 1 like stairs. The blue line is doing the same thing, up 1, left 1, up 1, left 1. So it looks, and I could justify that these two lines are parallel, therefore they will never intersect. So they have no common point. meaning the system has no solution. The system has no solution. So this is an example of where you would get no solution for a system of equations. Now the next system, I'm going to do this one in blue. The next system wants us to compare 2x plus y equals 6. And I love the color here. 2x plus 2y equals 6 and x plus y equals 3. 2x plus 2y equals 6 compared with x plus y equals 3. That is the same exact line. So if I were to say what points do they have in common, what points do they both share, I think it's fairly evident that they share all of their points. So this is the same line. We call that coinciding lines. They coincide with one another. Coinciding lines share all their points. And lines have an infinite number of points. So there are an infinite number of solutions. An infinite number of solutions. So to recap, when we're looking graphically at what a solution to a system, a linear system is, we can look at the graphs of those linear equations and we can try and locate the intersection point of the two lines. In the first example, we used the yellow line and the blue line, and the intersection point was located at the ordered pair 1, 2. The second example, we looked at the green line and the yellow line, and its intersection was at 2, 5. Then we looked at special cases in which lines would be considered to be parallel to one another and not intersecting. That would be the green line and the blue line. When you have parallel lines, there is no solution. Then we looked at coinciding lines. Coinciding lines are equations whose lines are the same. So these two equations, x plus y equals 3 and 2x plus 2y equals 6, form the same line graphically. Therefore, their intersection points, or the points that they share, would be all of their points, making the solution have an infinite number of solutions. I'm going to stop right there, and we will finalize this lesson 3.1 by actually solving a system from beginning to end and creating the graph on our own. Hopefully you found this helpful, and I'm looking to finishing up this lesson in the next video.